And do you guys still see the same screen? Cool. All right. So section 8 is going to be another like kind of 180 section, because last section we were doing SQL, whereas this section we're doing basically not SQL. And just so you know, this is actually a pretty short section. I think there are like 5 labs, including the intro and the recap. So there's not too much. The reason being, NoSQL databases exist in many different forms and flavors. And the one that we're going to talk about is MongoDB. And there are just other softwares that do the same thing. Pretty much that if you know how to use MongoDB and do these CRUD processes that I'm going to walk through, using all these other ones are going to be pretty similar. And I think they do talk about what are some examples of other ones. I'm going to be honest, I personally haven't used any of the ones that aren't Mongo, and Mongo I've only really used once. There, Couchbase. Couchbase is another one. But yeah, these are all, anything that isn't in table format is called a NoSQL database. And under NoSQL database, MongoDB is a kind of NoSQL database. So that's like the hierarchy of how you would classify things. So NoSQL databases are useful because in some cases you want to store documents. Tables are great when things are consistent, when we have the same columns for every entry. But in this case, we have documents. So imagine you have nested dictionaries. Nested dictionaries is the most common kind of data that you would want to put in a document store. And imagine you have a nested dictionary, and for each entry, you have different levels of nesting, different keys, different key value pairs. And in those cases of having inconsistent data, having something that's a document store is better, because you can account for those differences. You don't have to worry about like, okay, well, in this row, there isn't the values for these columns, so therefore we have to have those as null values. So that's really the big difference between SQL and NoSQL. That NoSQL is just for storing things like a nested dictionary. So let's see. These are most of these like these big chunks of text are mostly copied over from the labs, so they might look a little bit familiar. But all right. Main points. Each document contains key value pairs with data being stored as the value. And then we can talk about different schemas later. But all right. I think the main thing that we want to learn here is how to work with these kinds of databases. They're kind of similar to how we were working with SQL, but as usual, if anything just sounds foreign, please interrupt me. All right, so MongoDB is huge. I actually like this past weekend met someone who works there, and they're doing some pretty amazing things. So MongoDB is a version of, you remember how in SQL we were using SQLite? So imagine MongoDB being like a SQLite. Here are some steps for the installation of MongoDB. Every computer reacts differently. So I'm thinking that this week's one-on-ones, if you guys start working on MongoDB, if you don't have like a Mac that isn't running Catalina or whatever it is, I feel like you might run into problems. So please let me know if these steps don't work, and let me know what kind of computer you're using and what versions you're running, and I'll look for the right resources for you. But these, I think, work for Macs before Catalina, because I was running all this code today and I had just upgraded my computer and I ran into a bunch of issues. So that's going to be a little bit annoying. But anyways, we're going to start by installing these. So I've already done this. So imagine that I've already installed MongoDB. And here, the reason why I'm sharing my entire screen is just that when you want to start working with a MongoDB database, you have to spin up a Mongo client server. And so that's what we're going to do. So after this is all done, it says here to run a server, if you're using most operating systems, you would type mongod and the server will spring up on its own. Because I'm on a different operating system, mine is actually different. Mine is actually called brew services run MongoDB -- community. So if you have a Mac running Catalina, you'll be typing this stuff as well. But anyways, this is how you would run.
Same thing for the Windows also?
Yeah, to be honest, not too sure off the top of my head. I do have like a bunch of resources for each OS, but I don't remember the commands for each one. I'd say try just doing mongod first. And if that doesn't work, please send me a message and I will let you know. Because I think even for Windows, if you're using different Windows OSs, they might also be different. So anyways, what I did was, let me make this terminal window a little bigger. What I did was I typed in for Catalina, brew services run MongoDB community, and it says successfully ran the community. It doesn't really give us much information here, but several things you can do. So you all had downloaded Homebrew when we were setting up our environment. And so Mongo is actually run through Homebrew. So what's cool is we can do brew services list. And what we'll see here is you can see that I'm running MongoDB and it's currently running. And so in order for me to like interact with anything in this Mongo client server, I have to have this running. On the opposite of that, if you want to shut it off, you actually have to go in and shut it down. But instead of doing run, you would do stop. And that will stop your Mongo thing from running. And I think also if you close out the terminal window, it would stop automatically as well. But anyways, let's run it again.
Just one quick question. Are we going to install anything for the SQL database?
So
SQL database?
Yeah, so SQL, no. SQL, you actually don't have to install anything, which is very, very convenient because SQLite 3 is actually built into Python and is built into Python that we downloaded with Anaconda. So that's actually a really convenient thing about SQLite 3. Because MongoDB is a third-party database. Like MongoDB, it's its own company, separate from, like it's not Python specific. It is used with a bunch of different programming languages for a bunch of different reasons. So because of that, we have to install MongoDB. Yeah.
Okay.
So I'm just gonna run this again. And just to check, I always like to make sure that it is running. You can see that is starting. And one more thing, whenever you're running any sort of client server, this is where it gets into a bit of like hardware, I don't know, computer theory that I'm not even too sure about, but it is running at a certain address in your computer. And the way you check that is you type in Mongo, and it sort of does something that's similar to when you run Jupyter Notebook. It's actually springing up a shell, Mongo's own shell, if that means anything to you, and if it doesn't, don't worry. But here you can see that this is the Mongo shell, and it's connecting to MongoDB at this address, and there's also a session ID. So this will come back later, we'll see. But the rest of the things less relevant. Just so you ever, we'll see later in your labs if this number doesn't match, that could be a thing to troubleshoot. And we'll get back to this later. But anyways, to quit out of this, Control C. It's pretty cute. They say bye. All right. So just to double check that it's still running. Cool, still running. So if you're working with Mongo in your Jupyter Notebook, you have to make sure that this is running in order for it to work. All right, so here we have connecting to Mongo through Python is very similar to how we were connecting to SQL using that cursor connection. So here are some things that we're going to import. PyMongo is the Python library built to work with MongoDB. And here, actually, these are two lines that are actually from section 10, but I actually wanted to show you really quickly how I'm going to web scrape a bunch of data really quickly and put it into a Mongo database. So these two lines, I'll talk about it more in depth next week, but just know that these two libraries are for web scraping. Let's import that. So first thing we have to do is we have to set up the connection with MongoDB. And we do that through pymongo.mongo client. So remember this number that we see, this like 21017. Let's just go back to this again. Mongo. That number has to match this number here. So if you have an error when you run this, it's very likely that your number doesn't totally match, and by default it should connect to this number, but let's say you're maybe running something else on this exact address, you could it could start running it at a different address. That's how I understand it. So that should match. So when I run this, it's connected. Now, so we're in this client, and in a client, you have different databases. That's where you store all your databases. And so let's just take a look at what databases we have. Cool. We have an admin config local. These three you should have by default. I think they are created by default just to store like important information pertaining to your computer and to your client. If you haven't run this before, this won't show up because this is exactly what I'm gonna put in later. So cool. So what I'm gonna do is there's this neat website called Quotesdiscretecom. It is a website just designed for people to learn how to web scrape. And we'll talk about this again next week. But just know that on this page, you have a bunch of like quotes by different authors, different people with tags. And I just want to take all this information and store it in a Mongo database. And how I know, or why I think it's an appropriate place to store is you have the quote itself, the author, and you have these different tags. And something that gives me a clue as to whether I want to use a NoSQL database is if I have something like this, where the number of tags are a one-to-many relationship. If we remember that from SQL, if I have like, it's not a set number of tags per quote. Or yeah, and it's like each quote can have any number of tags, and they like don't have to be exclusive. So cool. This is just some scraping code. It's pretty cool. We'll actually learn about this next week. But this is a function that will take all the information on that web page and store it in a list of dictionaries. So let's take a look. That list of dictionaries now looks like this. And to start, I only scrape the quote and the author. So here I think we have what? Let me see how long this is. I believe 10. Yeah, so here we have 10 quotes. And each one of them is a dictionary with the quote itself and the author. And so this is the information that I want to store into Mongo. And Mongo works really well because it automatically takes lists of dictionaries and it knows that each dictionary is an entry. That's awesome. So Mongo itself also works like a giant nested dictionary. So as you see, we start with the client, and the client is what stores all the databases. So first, we're going to start with my client and create a new key, the key of the client being each database, and then create a collection. And so as you remember with SQL, when you have a database, you can have multiple tables. In a Mongo or a NoSQL database, in a database, you have, instead of multiple tables, multiple collections. Got it? So tables are to database in SQL what collections are to database in Mongo. So this just creates the database and the collection as well. So if you didn't run this before, this would be added. No, this wouldn't be added, but after we insert quotes, that would be added. And that's because of this. This is something that you can read. Let's see. This is just to reset the database, so don't worry about this too much for now. Oops, wrong. Cool. So we have this data here that lists the dictionaries with just like quote and author. It's super, super straightforward. All I have to do is my collection dot insert many, and then feed it that list of dictionaries. And also I'm storing that action as a variable, and we'll see why in a little bit. So here, I'm doing this action, storing the action as a variable, and then ideally it should show that this should finally turn up in the list of databases. Why I stored that as a variable? Because the action also has attributes. So for example, here in the results, we can see what IDs were inserted. So this is just to make sure that you inserted a bunch of things, right? So earlier we had 10 quotes, and these numbers don't really mean anything, but the main thing we want to check is that you inserted 10 objects. And those are just something that you can use to this is just something you can use to double check that everything was inserted properly. And that's it. We've inserted our data into our database. Any questions so far? Cool. Awesome.
Well, basically, we're just watching along with you because we don't have Mongo installed right yet.
Yeah.
So basically, Jupyter will interact with Mongo on your machine.
That's right.
Okay.
So we're creating this database locally on your machine at that address. So it's not, I don't really know how to explain it, but it's not a database that it's not a database file that we can see. But as long as we go to that same address, we will find those databases.
Okay, Ish, I was trying to install the Mongo now. And hello?
Yeah.
Yeah. So when I went to the first step, all the files got downloaded. The second step where it says that sudo make directory -p data.
It broke.
So here I'm getting an error. It says that the sudo thing is not found.
Okay, yeah. So you're running a Windows computer. I can't answer that right now, but I will send out a Slack for everyone who's using a Windows, and hopefully that will help.
Okay.
Yeah. All right. Okay, so yeah, let me just make a note to do that. Okay. All right. Okay, so here we've demonstrated that there's now data in this MongoDB database. Next, very quickly, how we query data from Mongo is actually pretty neat. I like the way that querying is done here because it's very Pythonic syntax. So there is a .find function, which I feel like makes a lot of sense. So what we're doing is we're looking into the collection, and what we're going to do is find all the key value pairs that match author equals Albert Einstein. It's really that simple. And when we do this, we see here something that kind of looks familiar. It works in a similar way as the cursor does for the SQL database. So here we have this cursor object, which is interestingly iterable. And so because of that, we can just for x in query print x. You can print x, or you can store x to another list of dictionaries. So here we go. We can see that we have 1, 2, 3, 4, 5 different quotes, all by Albert Einstein. So we wanted to do other authors. Let me see, who was another author? Let's see, Steve Martin was in there. And I have Steve Martin's quotes. I see that in my database right now, I have duplicates, and I think it's because I didn't clear my database. So just to know, if you're running this notebook again and again, I have that line somewhere. I have that line here. That is to reset the database. So what this does is it completely deletes the collection. And I'm not gonna lie, like this is something that when I was working on a project using Mongo, I ended up using this a lot because I would put in data, realize that my data is not as clean as I want it to be, delete the whole thing, and re-put it in a clean way. So I'm just going to do this really quickly and then reinsert the quotes. And hopefully now just one Steve Martin quote is there. Cool. So what I did here was I deleted everything. I deleted the entire collection and then just reinserted things once because I think before I started, I already had my database populated. Cool. So querying, I think, is really straightforward. You can also query multiple, if you feed it in like a list of dictionaries, you can give it, sorry, not list of dictionaries, but if you give it like multiple key value pairs for the dictionary, I think that'll work as well. So let's try this. Here we go. There we go. Well, because it's the same one, it looks like that. Let me pick a different example so we can see. If we're searching for this specific one, we can give it this. There we go. Because I have to do the find here. And there we go. So you can feed it in many different, if let's say like your data has like a bunch of nesting in it, you can feed it any of the nested data, any of the nested key values, and you can search that way. Cool. All right. So we've gone through two out of the 4 processes in CRUD. Did I mention CRUD at the start? I don't know, but CRUD is one of the main processes when working with any database, and CRUD stands for create, read, update, and delete. Very often you'll see on job applications, if it's something that's more on the data engineering side or like the working with databases side, they'll ask for CRUD experience. And so what we've already done is we've created the database as we did right here and inserting the data into Mongo. We've read the data by querying specific quotes. We're going to talk about update in a little bit, and we actually just saw like one instance of just deleting everything, but I'll also show you deleting specific rows of data. So cool. Let's move on to the U of CRUD, updating data. So updating data in Mongo, I think, is also really elegant. So imagine you have like one data point that has an extra attribute that you wanted to add to it. So in this case, I found that like, okay, Steve Martin's quote has these tags. Let's see where it is. Steve Martin here. Is it this one? I don't remember which one. But anyways, Steve Martin's quotes has these tags, and I just wanted to store that data as well. But I, for some reason, just don't care about the tags about the other people for now. I just want to store that data because I just found it. And I just want to get that in the database as soon as possible. So let's say I just found this list of tags that I want to store. The syntax for this is a little bit complicated, but I think it makes sense. So first, you have to tell which subset of data to update. And we're going to update the subset where the author is equal to Steve Martin. And then there's this set parameter. So this set parameter is every time you want to add new data. And then what we're setting is we're going to create a new key called quote tags. And the value we're going to assign this list of tags. Cool. So these are the 2 things that we have to define first. And then we just call on our collection, update, which subset of data to update, and what new data to add. Cool. So it takes in 2 arguments, subset of data that we want to update, and then the new data to add. So once I run this, we see that there's an update result something. And now when we query for Steve Martin, we can see that now we've added his quote tags, and it's already stored in the database.
I have a question.
Mm-hmm.
So if you have multiple quotes by Steve Martin, all those quotes will be updated with those tags.
That's a good question. In this case, yes. No, sorry. In this case,
so you have author Steve Martin is your
yeah.
As long as the author Steve Martin has a.
You're right.
Okay.
So in this case, yes, it will update. Well, if this is, so in this particular case, because I used update 1, it wouldn't. Wait, let me think. No, actually, no. I think that this will, yes, this will update everything with Steve Martin in it. Because if you want to only update this particular quote, and if you had other Steve Martin quotes, you would have to like tell it which quote as well.
Okay.
Yeah, I think the update 1 is a different, I don't remember why this is the syntax, but that's referring to a different one or many. But yeah, that's a good question. I do have to double check.
Okay, another question is, like you said with querying, like as long as you know, you have author Steve Martin, does it matter how, like when you define how deeply nested something is?
I believe
or will be able to find no matter what?
I believe it's I believe it doesn't matter. That is also something I need to double check, but I believe it does not matter.
Okay.
So cool. That is the U of CRUD. And finally, delete. We saw that earlier. If you feed it in, where is it? Here. It has delete many. And if you delete many and you feed it in empty curly brackets, it would delete the entire collection. So remember, you might not want to do that. In this case, we can delete all the quotes by Albert Einstein. So that's why I think that this one, even though it says update 1, it updates all with Steve Martin, because here it deletes 1 and it still will delete all the instances of Albert Einstein. So I believe if you feed it in a list of dictionaries, it would delete, then you would use delete many. And similarly here, if you use update many and you have like different parameters that you give it, then you would do many. So that's the difference between 1 and many in this context.
So what happens if you delete it with error? I mean, you're not willing to delete, but then accidentally if you delete, then
yeah, if you accidentally delete it, it's gone. So that's why like you should always have your code to reinsert things. Yeah.
And is there any way to revive it then?
Unfortunately, not that I know of. Not that I know of. There might be, but it's not something that I'm super familiar with either. But yeah, here, very similar to updating and adding data. To delete data, here we're just gonna delete everything that has the author of Albert Einstein. So before I delete, let's print this out. And we see that Albert Einstein has 3 quotes here. Here we're just feeding it in the delete 1 of Albert Einstein. Delete it like this. And then, oh, interesting. That's not what I expected. So maybe it does delete 1. Yeah. I guess this just shows you how important Mongo really is. But yeah. So it does delete 1. I have to double check on the updating for you, and I will Slack it to the channel as well. But yeah, I honestly haven't used Mongo in my own personal project since I had to use it I decided to try to use it for my capstone. Didn't really work out because I found out my data was better in a table anyways. So I ended up using, actually ended up using a CSV. But yeah, if you're more interested in like data engineering work, definitely Mongo is important. Cool. But yeah, that's about it. It is a shorter section. I think in a way that's similar to SQL. I mentioned how like even with SQL, there are many different kinds of SQL. And so like the syntax for the different kinds of SQL differ a lot. And I think in a similar vein, when you're doing NoSQL databases, Mongo is only one of many, many different kinds. So I would say the only way you will end up using Mongo is if you have like for one of your projects, if you end up using like a large nested dictionary as your data structure and you just want to store it somewhere, then you would use Mongo. But otherwise, I'm gonna be honest, I think I would say like less than 5 of my students ever have ended up using Mongo. but it's always good to know at least the basics. Cool. Any
for the project, will it be right? Will there would be database where we have to pull it from Mongo?
No, not at all. Not at all. No. So for the project, I mentioned this at a couple 101s today, but the project will be all CSV files. So they're all like table data. So the thing is, for the project, the minimum that you need to do is just take these data from CSV, use like pd.read CSV, and then do your data cleaning, and you're done there. If you want, it's definitely an option to take those tables from your CSVs and turn them into a SQL database. That's more of like a level up if you really want to like, get familiar with SQL. And that I can definitely help you with. But that's not necessary. So yeah, you don't have to worry about Mongo for your project.
Fine.
Yeah. I'm just gonna try and see what happens when I delete menu. So there is a delete menu. Okay. Yeah. So that's good to know. Cool. Any other questions? Awesome. Yeah, as I mentioned, Mongo is a short section. It's also something that's very specific. As a data scientist, you end up using Mongo only if your company is using Mongo. And out of actually all of my students that I've had, I think one person uses Mongo at their job, and she works at MongoDB, so that makes sense. But otherwise, I think it's something that's very specific, but it's good to know how to work with a NoSQL database for sure. But cool. The next couple of sections are talking about getting data. And this is retrieving data from the internet through APIs and through web scraping. So that's going to be another switch in like the stuff that we're doing. Definitely, I will say, and I think it's already obvious that like, MongoDB is not a priority. So if you were to skip a section this mod, I would say this would be the section to skip. Like, yeah, definitely, because 9 and 10 are going to carry a lot more weight. Thing is, for like section 8, is not going to come back in any of the later mods, and it is something that really only if you're truly interested in going somewhere that uses Mongo or that uses a NoSQL database, they can that I would like go back and look at. But JSONs and APIs, as well as web scraping, they are going to come back. You're gonna end up using these sections in your future projects. So if you want to like to prioritize, that's how I would prioritize. Just so you guys know. All right. In that case, I have nothing else for you guys. As usual, anything you need, send me a Slack. But yeah, in that case, have a good night, everybody. Bye.